Hi guys, let's take a look at this question. The reaction of calcium carbonate and excess dilute hydrochloric acid is used in to the investigation one of the factors that affects reaction rate. And they give us the balanced equation, lucky us. The same mass of calcium carbonate is used in all experiments and the temperature of hydrochloric acid in all experiments is 40 degrees. The reaction conditions were summarized right here. For this investigation, write down the dependent variable and the independent variable. Okay, so the independent variable is the one that you change, and the dependent variable is the one that changes because of the independent variable. So the dependent variable here would be the reaction rate, and the independent variable will be the surface area or the state of division, you could call it right here, state of division. Okay, it's the thing that we change, and then the reaction rate changes because of that. Okay. Then they give us a graph. They tell us the carbon dioxide gas produced during experiment A is collected in a gas syringe. The volume of gas collected in is measured every 20 seconds, and they give us the results here. Then they ask us, what can be deduced from the graph regarding the rate of the reaction during intervals or time intervals 20 seconds to 40 seconds. So we have 20 seconds to 40 seconds. What happens here? We have a decreasing gradient. And when we have a decreasing gradient, in terms of the rate of reaction, the rate of reaction is decreasing as well. Then from 60 seconds to 120 seconds, we have a gradient of 0. And what happens when the gradient is 0? The rate of reaction is also 0. 5.3. Calculate the average rate at which carbon dioxide is produced in the experiment. Okay, so how do we calculate average rate? Like that. So we take 560 and 0 and 0. So it's going to be 500 minus 0 over 60 minus 0, and that should give me 8,33 centimeters per second cubed. 5.4. How will the volume of carbon dioxide gas produced in experiment B compare to that produced in experiment A? Use greater than, smaller than, or equal to, and that will be equal to. 5.5. A graph is now drawn for experiment C on the same set of axes. How will the gradient of this graph compare to the gradient of experiment A? Greater, smaller, or equal to, and then use the collision theory to explain your answer for 4 marks. So you'll get a mark for saying greater than, smaller than, or equal to, and then you'll get your 3 other marks for your explanation. So it's going to be greater than, but why? So the surface area, right, of calcium carbonate granules is smaller, so therefore we have less particles with correct orientation. So what happens? We have less effective collisions per unit time. And because of that, there's a decrease in the reaction rate. And that is why the gradient will be greater than. And this is now for experiment. I used experiment C to explain this. Okay. You could have also used experiment A to explain. You could have said, oh, the surface area. Well, sorry, I use experiment A. I use experiment A. You can use experiment C and say, oh, the surface area of calcium carbonate powder is greater than the granules. So there's more effective collisions per unit time, which will increase the reaction rate. Okay. And that's it, guys. I will see you in the next one.